So Debbie will join us in a moment. Let's put that over here and share the desktop. Share. Whenever you want. So one person already took it last week and did very well. It's very exciting. You can take it anytime now. I just needed you to experience it once first to know if there's anything you need to brush up on, to do some practice with. All right, so for activities in chapter 5, we're going to do 1, 5, and 6, and we're going to get some of that done right now. And so we're going to jump into activity 1. Let me get that loaded on the screen. Where are you? Here. And make you go away and blow you up just a little. Okay, so when we played with whole numbers, we had to model what is a whole number. And a whole number could be a thing like a G.I. Joe doll or a finger. And we needed to know what they were in order to figure out how to add, subtract, multiply, and divide with them. Same thing's true for positive and negative numbers. And one model for positive and negatives is the idea of charged particles. That a positive number is a positive charge, a negative number is a negative charge. And you'll have to teach this to kids also, but what happens when we put a positive charge and a negative charge together? They cancel each other out. A positive and negative cancel each other out. So we're going to go on that premise. So another way to think about it is in terms of like gain and loss. I gained $1, I lost $1, what happened? It's a wash, I'm back to 0, right? Football, I gain a yard, I lose a yard. Where am I? Right back where I started, okay? I got a positive point in class, but then I get a demerit. Where am I? Right back where I started, no change. Okay, so kids can grasp that idea. And so then we use these different chips to deal with it. So in class here, we have red and yellow or red and white, depending on which set of toys you have. On the board, on the screen here, I have black versus white. Okay, and so we have to make a choice on this. And so let's say they made a choice here for us. Use a dark chip to represent a proton, a positive, and a light chip to represent an electron, a negative. So we could then, to do a similar thing with your chips, red would be positive and white or yellow would be negative. So with that in mind, I can start drawing. So we're looking at the charged particle model. Charged particle model for integers. Does everyone know what I mean when I say integers? Or the better question is, anybody not? Whole numbers are integers, but they're more than, integers are more than the whole numbers. Includes the negative numbers, right? Yeah. So the integers are the set of numbers like 0, 1, 2, 3. Those are the whole numbers going on forever. But it also goes the other direction, -1, -2, and so on in the other direction. So if you take the whole numbers and their opposites, you get the integers. Okay, the whole numbers combined with the opposite of the whole numbers. What's the opposite of 1? What's the opposite of 2? What's the opposite of -3? 3. What's the opposite of 0? 0. Oh, you guys are awesome. Right on. Okay. So we're looking at the charged particle model. There's also a number line model that's used a lot too, and that's in the book. Feel free to take a look at that. I'm not going to go over the number line model though. I'm just going to do the charged particle. To do the charged particle model, you need a key. Charged particle. And so my key would look like this. A solid one is a positive 1, and a not solid one, a white or yellow, is a -1. And if you put a solid one together with a not solid one, you get nothing or 0. you get a 0. And I'm putting the slash through it to indicate it's a 0 and not a charged particle. All right. So with that in mind, I can make sets of things. Like if somebody says, okay, in this model, what does -3 look like? Oh, cool, -3 looks like that. There's -3. What does 4 look like? 4 looks like this. To the best of my coloring ability. So that's 4. However, the charged particle model gives us a little more freedom in dealing with numbers because I could sneak into this set for 3. Those two guys. What's the net value of this set I have circled here? It's still -3 because those two cancel out. Those two make a 0. Or you could say those two make a 0. It doesn't matter which two you pair together. The net charge here is -3. And that's going to give us a lot of power when we're playing around with other numbers. So let's just take a look at some of the things we're asked to do in this worksheet. Hi, Debbie. How are you?
Good.
Good to see you again. Oh, I wonder if my speaker's off. I didn't hear you. Do you have a microphone?
I do.
Let's see. Hang on. How do I get my settings back? I can't hear you at the moment, but maybe I can figure out how. Oh, right there.
Can you hear me now?
Settings. Says I have a microphone. Oh, and it's the microphone that's turned off at the moment. Okay. Which is that? This one right here? Oh, that's the microphone. That's this one, I think. Oh shit, did I just lose it? No. Speaker. All right, try saying something now.
Okay.
Oh, I can hear you now. Shit, sorry, I had the wrong speaker on. Oh, good. Debbie's talking in my head. Sorry you guys can't hear her. All right, cool. All right, so we're back. All right, so I can hear you. So you can ask me questions now. I'm sorry I couldn't hear you before.
It's okay.
I feel foolish. All right, so let's take a look at our project. So basically they're showing some things here. This set right here is really 2 because you can wipe out a couple of these by saying that's a 0 and that's a 0. So there's only 2 positive charges left, and then demonstrating that over here. Same thing here. This is another way to say 3 because you 0 out some of the charges, and there's only 3 negative charges left. So what they want you to do here is in 2 different ways with the chips can you show what it means to be 5. In 2 different ways can you show what it means to be -1. Okay. So play around with your chips for real and on paper. I'm going to draw some in here too. Let's see, I can copy that into my clipboard. Let's see, pen. I wonder. Can I do that? Looks like I have to draw them by hand. Oh well. Oh, I have an idea. If I do that. Aha. Yeah, so for example, I could show, that's one way I can show -1, or I could show -1 with a couple of those, and then I could copy this over, steal. Is it gonna let me steal it? Ah, darn it. Hang on, let me do this. Control C, put you back. So this is also a way to show -1, because these two 0 each other out. Okay, so I want you to come up with 2 ways to show each of these numbers. think my pen would be easier. Ah. There we go. Sorry, people on the internet, this is kind of boring. Is it? Yeah. Oh, did I mess it up? Ah, darn it, I messed this up. Oh, I got rid of it all.
Do we need to circle the pairs that cancel out?
No. You don't need to circle the pairs that cancel out. Okay, so I think I got my homework done here. So we'll talk about these in just a second. What's going on here, Hillary?
My teacher, when I was in like 7th grade, she tried like to do this.
Mm-hmm.
So it always goes in dirty.
Oh, all right. The absolute value car wash. Cool. So I have one way you could do it, and there's a ton of others. Right? We could do these all day, make these. There's always a way to make it with the least amount of toys. What's the least amount of toys I need to make a 5? 5 toys. What's the least amount of toys I need to make a -1? 1. Least amount for 2? How about -2? How about 0? None. Yeah. And that idea is what's called absolute value. How many things do you need to make that happen? I need no things. I need 1 thing. I need 5 things, or I need 2 things. I don't worry about whether they're positive or negative, red or white, red or yellow. It's just how many things were there. And that's the idea of absolute value. And that's what the next page is getting to on this activity. Oops. Oh, wrong button. So question number 2 is getting at the idea of absolute value. What's the fewest number of particles or toys you can use to represent any one of those numbers? So the fewest number for positive 5 is 5. The fewest number for -2 is 2. And so absolute value is an important idea also when we're working with integers. We have positive, we have negative, we have 0, we have absolute value. The idea of being the opposite, that's a whole nother tricky thing. What's up?
Over here, would you accept a blank spot?
Yep, I would totally accept a blank spot. Yeah. Yeah, so the question was on this part right here, can I put nothing as my sketch? Totally can, yeah. It's 0. So Debbie, for the activities, originally I said we were going to do activities 1, 2, 4, 5, and 6, but I've whittled it down. We only have time to do a few, and so we're going to do just activities 1, 5, and 6.
Okay.
And so we're doing 1 now. We'll take a look at 5 in just a moment. But I got something quick I got to do before that. Let me remind myself what 5 is. Correct. Absolute value of 0 is 0. Yeah. One, 5, and 6 are the activities we're doing. 1, 5, and 6. All right. So I'm going to move away from this activity for a minute because I want to show you some other things we can do with charged particles. So we can use them to add. So we've got a definition for what a charged particle is. So I'm going to put my key back up here. That right there is a 1. That right there is a -1. And when I put two of them together, besides having nothing, that's another way to indicate that I have 0. Right? So if I want to do addition with these things, I have to state what addition means. Well, what does addition mean? Anybody remember our first definition of addition? Combine and count. Yeah, combine and count. So with this key here, and the fact that addition means combine and count, oops, I can now use the chips to show how to add count. There we go. How to add signed numbers. So for example, if somebody said, you know, I'm not going to worry about basic ones like 2 plus 3. We got that down, right? We did that before. But what about -2 plus -3? Well, show me what -2 looks like, okay? -2 looks like that. What does -3 look like? Oh, okay, -3 is 3 of those. What's add mean? Well, it means put them together and count them. Okay, put them together. What do we count here? 1, 2, 3, 4, 5. 5 what? 5 negatives. That's important. So this has to be -5. Okay, that's not bad. I mean, there's other ways to teach it, right? Gain and loss is a really powerful tool. We'll talk about that next class. Can I do something like 3 plus -5? Turns out I can. Show me 3. Okay, 3 of these solid guys. So 1, 2, 3. And then I want to combine that with 1, 2, 3, 4, 5. And I put them together in one big set. But I got a little more work to do to count them. What do I have going on here for counting? Yeah, these guys can cancel out. And these guys could cancel out. And maybe these guys could cancel out. So there's a bunch of zeros. And what's left here? Careful, what is it? -2. Yeah, there's 2 things and they're negatives. That's one reason having the key there is super important. We need that key to remind ourselves what these things mean. And so this is like a game we can play with kids, isn't it? Right? You got these chips in front of you. You lay them down. Your partner says, hey, we can make some zeros here. Check it out. There's a 0. There's a 0. Hey, look what's left. And they repeat this a bunch of times, and eventually they see, oh, that's interesting. Sometimes when I add 2 numbers with opposite sign, the answer is negative. Other times when I add 2 numbers with opposite sign, the answer is positive. Is there a way to tell when the answer is going to be positive and negative? Right? That's going to come out in the discussion, and then you can develop a rule for that. Right? And couldn't the kids develop the rule after playing and playing and playing if you guide it the right way? Yeah, they could totally develop that rule. Might they remember it more if they help develop it instead of you just tell them?
Yeah.
Did you ever look up the rules for adding signed numbers? They're a nightmare. Find a pre-algebra book or a basic algebra book and look up integers and look at the rules they give you for adding. I'm going to leave that as a homework assignment. Look that up somewhere. What are the formal rules for adding these numbers? You're going to read them and you're going to be like, what the heck? This is like the instructions that come with building a backyard grill. Just, they don't make any sense. Somebody from Guam wrote it. Not that there's anything wrong with Guam. It's a great place. There's a lot of smart people there. Okay. So, can we subtract with these chips? Okay. So, let's see, to subtract, we would, wrong button. To subtract, we already have a key, right? Our key says this guy right here is a positive and this guy right here is a negative, and put 2 of them together and I get a 0. All I have to do is state what subtraction means. What's the most popular definition of subtraction?
Take away.
Take away. We're going to go with that one. Yeah. So let's go with subtraction means take away. All right, let's try one of the harder problems for people. -5 minus -3. And usually we put them in parentheses if we don't want the negative symbol to get confused with the subtraction symbol, because they are two different things, even though we sometimes treat them the same. Usually on calculators, the subtraction symbol is bigger and the negative symbol is littler. Sometimes it's elevated. Okay, so let's see. So the way takeaway works, we start with something. What are we starting with here? -5. So let's show -5. 1, 2, 3, 4, 5. Okay, what's subtract mean again? Okay, so what are we taking away? We take away -3. So let's take these guys away. Take away -3. What does that leave us? Wasn't that remarkably easy? There's a rule we've learned, right? You're going to teach that to kids in a minute about how to deal with subtraction, or at least one of them. Right? Remember adding the opposite? You're all familiar with that rule? All right, let's look at a slightly harder version of this one. That wasn't too bad. Let's try, darn it, wrong button again. Let's try -3 minus -5. Here's where it's going to get a little trickier. Okay, what are we starting with? 1, 2, we start with -3, right? And I need to take away, ooh, -5. Do I have -5 to take? Darn it. Anybody have a trick up their sleeve? No, we're subtracting here. We are not adding. Sorry, that's not in our rule book yet. Is that the only way to draw 3 or -3? Aren't there other ways to draw -3? What could I do to draw -3 in a different way?
You can do three more negatives.
Put some zeros in?
3 more negatives, 3 more positives.
This is still -3, right? And isn't this still -3? Can I take away -5 yet? 1, 2, 3, 4, 5. Oh my gosh, I can take away -5. Am I still starting with 3? But I had to tweak it a little bit. That's okay, we tweaked it because we know there's different ways to use these toys to make a -3. Now we can take away the -5. Oops, away, -5. And that leaves, oops, I'm messing up here. That leaves, there we go, a +2. Would you agree from, did I screw up again? The leaves, oh yeah, that's leaves, oh gosh. Someday I'll take a spelling class and a handwriting class and a few other things. That leaves +2. Okay, now Christian was thinking back into this previous life he had. He's reincarnated now in this class. That he used to take that and he used to rewrite it as adding the opposite. Okay, -3 plus 5. I'm still at a loss. Let's see, what's -3 mean? That's this right here. And +5 is these guys. And add means what? Combine them. Okay, so I combine them. Do I have anything else to do here? Yeah, there's some zeros. Come on. Come on, there you go. Let's see, so these two make a 0, those two make a 0, and those two make a 0. That leaves 2. Are these two totally different pictures? Yeah, totally different models. And you can, they just happen to come out to the same answer, which is, you know, so that's something we could illustrate with kids. We do one next to the other, and because we could just tell them, always add the opposite, okay? That's one of the most common things we screw up when we're working with positive and negative numbers. It turns out you can do it all the time, but it's only beneficial some of the time. So that's another question. When is it most beneficial to rewrite as adding the opposite? So we are at a time for fun now, but we can explore that later. Do it all the time? Yeah, it turns out you don't need to do it all the time. Sometimes it makes the problem harder. Sometimes it makes the problem easier. It just depends. And the only cure for that is experience, really, because you just keep building up these rules that you just get used to. But I definitely want you to look up somewhere, find a book either online or search the internet what is the procedure for adding integers? Especially when they have different signs. There's this really elaborate procedure. And we can talk about that next class. So we'll be able to bang out activities 5 and 6 in the first half hour of class next time. And then that's going to be the end of new stuff. If you happen to have some free time in the next couple of days to do activities 5 and 6, it's always good to get ahead. But I know it's the last week of classes and there's a lot going on. So at the very least, we'll finish those in class. And then we'll start reviewing. Is next Wednesday.
Not this Wednesday.
Next Wednesday, yeah.
Okay, you have me a full pack.
Yeah,
Like,
no.
I got a lot of people already for to take a test.
Yeah, no. Yeah. And there are sample exams on the website to take a look at to see what my previous finals. It is cumulative, yes. Yeah. Yeah, there'll be a little bit about sign numbers. There'll be a little bit about primes, composites, multiples, and factors. And then there'll be a little bit about each of the other things we've done. All right, I'm glad you got to tune in, Debbie.
Yes, me too.
That's it for today.
All right. Thank you.
Let's see, I think your mic is off, or did mine die? I can't hear you.
You can't hear me at all?
Let's see, let me try a different mic maybe, or a different speaker. Oh, it switched on me. How did it do that? Save. Okay, try saying something again.
Okay.
Oh, there you are. Oh shit, I did it again. I screwed up the microphone. All right, do you have any questions for me?
No, I think I understand it.
Okay, cool. Yeah, so we'll, there's a small homework assignment that has a little bit from section 1 and a little bit from section 2, and then we'll finish up the activities in class on Wednesday.
Sounds good. Thank you.
All right, bye-bye.
Bye.